Hi there, looking at exercise 7b and the laws of logarithms. This actual slide here has an old picture which I found off Google probably. It says the special properties of logarithm make solving equations a snap. I think it's meant to be quite funny. Meant to be. It took me a few years to work out it was meant to be a log with rhythm. There you go, it's a logarithm. Anyway, there's 5 rules here. It reckons are important, and we're going to go through these rules now. First of all, we've got 5 equations. This comes back to what we were doing last time. You need to solve these using logarithms. So see if we can do these. Pause the video and see if we can do them. Okay, I'm hoping you've done those. So this first one, for instance, you should have seen that becomes x is the log to the base 10. This 10 moves over and becomes a logarithm of 450. This one should be x equals log to the base 3, because this one says 3 to the x is 232. Now, those two are relatively straightforward. You should have got the right answers for those. I suppose the interesting ones are, and 5 straightforward as well, the interesting ones are with whether or not you got 3 and 4 right. So if we have a look at the first 2 answers on this, I got 2.65 and 4.96. Hopefully you got those. I'm going to do question 3 because I just think it's marginally different. The 4 moves over, but now that leaves me 2x equals the log to the base 4 of 15. Notice that's 2x, and the 2 doesn't go over as well. You leave the 2x. Now if I type in to my calculator the log to the base 4 of 15, what's it give me? It gives me 1.95. So if that's 1.95, now of course that is 2x. I'm going to give myself an extra decimal place or 2. 3. There you go. I now have to define x, so I have to divide this by 2. So it's 1.9534 shared by 2. So I'm going to divide by 2, and that's 0.977. Now it's worth giving yourself a couple of extra decimal places when you do other things to the number, and then hopefully you're still accurate. Hopefully you've done 4 right in a similar way, and 5 was a fairly straightforward one. So there's my answers to the others, but that was the only one I've actually looked at, but that was at least the right answer. So the 4 laws of logarithms, I think the original slide said 5, but I've condensed them into 4. But there is a link between powers and indices and logarithms, and that seems reasonable, doesn't it? Because they look similar, even if they're not really. One's exponentials rather than indices, but you get the idea. So if we look at this, indices, then the one rule that we see all the time is that you times the powers, you really have to add the powers. And then this is the equivalent. It says if you are timesing a logarithm, then you can split them and you add them. So notice this. So if I join 2 exponentials together and times them, it becomes an add. If they're already times and we're doing the reverse, I can undo that and split them, and I get log x plus log y. So you can see there's a direct analogy between the two. Now look at the equivalent for division of powers. So we know that we have to take them away. So don't be surprised that when you log x over y, it's log of x minus the log of y. It seems obvious when you see it like that, I think. Law 3 says if you times 2 powers together, it must have been one of these a to the x to the y. A power to the power is a to the x times y. Now this is, it doesn't seem as obvious, but this is what we're going to treat it as. So the rule basically says if I have log to the x to the power of k, I can bring this k down to the front, and when I bring that k down to the front, it becomes k log x. Just bear that in mind. By the way, these work for all logarithms. It's not specific to a particular logarithm. And my last one is the equivalent of a to 0 is 1. Anything to 0 is 1. We should know that from GCSE. And any base logarithm, log of 1, will give me 0. So they do look the same. The only one that looks slightly different is this law 3 on both, but they can be shown to have equivalences. We need to write these down, we need to learn these, off by heart. So expression there, it says express the following in terms of log 2, log 3 and log 5. Now the other thing I'm looking at here, it says log 15, and I'm thinking, oh, a bit, if I do what I just said, log 15, you can think of that as a times, and I'm thinking of it as 3 times 5, and I'm thinking of that because it tells me I can use logs of 2, 3 and 5, and 3 and 5 is what I think I'm going to do. And we just saw that when you times two numbers together and log them, you can treat that as log 3 plus log 5. Now you might doubt that, but just type it into a calculator. What is log 15? Log of 15, just do log to the base, pick a number. Let's pick to the base 4. It doesn't say what. So I'll say log to the base 4 of 15, and that is 1.95. Now I'll do log to the base 4 of 3, and move out the bracket, plus log to the base 4 of 5. And it says 1.95, which is good, because that's what I said it was. So this rule works for all logarithms. Now I should point out, usually if they don't leave a number in here, they usually mean to the base 10. So just bear that in mind. If it doesn't say a base number, you should assume it's 10. Here I did it for anyone, but if I did it to base 10, it would have worked as well. Now log of 16, how can I use 2, 3 or 5 to get 16? And you might think for a moment, oh I see, yeah. So I can do log, I'm going to have to do 2 to a power, I think. And 2 to the 4 is the same as 16. I think I showed you that on a recent video. 2 times 2 times 2 times 2 is 16. So I can replace log to the 16 as log of 2 to the 4. And one of my rules says I can bring that 4 down to the front. So I think that's 4 log 2. And this time we'll type it in. Let's type it in log to the base 10 of 16. And we'll do 4 times log to the base 10 of 2. Let's see if we get the same answer. So again, I'm going to type in log to the base 10 of, what was it? It was 16. And I get 1.204. So now I'm going to do 4 times log to the base 10 of 2. And I get 1.204. It worked again. So how am I going to do this? So log of a third. Well, the obvious thing is to write a third as 3 to the power of negative 1. You can see this is power of 1, but it's on the bottom, so it's 3 to the minus 1. So this equals the log of 3 to the minus 1. And I think I do the same trick. I think I bring that down as a power. And that means it's minus. Well, I could write minus 1 times by. I will do this time, but I could have just written minus log of that. You see the minus 1's come to the front. I'm going to change that. It's minus log 3. So again, if I do that, I'm going to type in log of a third. Now, I'll do to the base 10 again, since it doesn't tell me otherwise. So 1/3 in brackets, and I get minus 0.477. That was the original answer. And now if I do negative log to the base 10 of 3, my new answer is minus 0.477. So my answers actually work quite nicely, and they are the correct answers. So express log of a b squared in terms of log a and log b. Alright, so we've got this expression. I suppose there's a temptation to bring the 2 straight to the front. We had that rule, didn't we? We had log to the base. I'm going to make it up x to the k. I can't remember if I used those letters, but I said you can bring that k to the front. K log x. That's one of my rules. But there's also another rule that said if you have log of x, y, you've got 2 things times by each other, you can split them and make them a plus. And I think we need to do that first, because this is a times b squared. It's only the b that is squared. So I think this becomes the log of a plus the log of b squared. And now I can bring the b squared, I can sort that out, and I can bring the 2 to the front, and I think it becomes log of a plus 2 log b. That's the kind of rearrangement you're expected to do in exams. And there it is, log of a plus 2 log b. Simplify these logs. writing them in a single logarithm. And so this is the other way around. This is not me trying to split them like I was just doing. And notice on this one, we had one logarithm to start with. And it said write it in individual parts. Whereas this question, I've got the individual parts and I want to join them together. So this is very definitely the other way around. So just remember, if I add them, I have to times them. So this becomes log. And I'm going to do 5 times 2 because it adds, that's my rule. But it says minus log 3, so I can actually do over 3 because a minus is the same as divide. So I think this is the log of 10 thirds. It's not very nice, but it's a single logarithm. I think that's right. Now what am I going to do here? I've got to join them all up. Well, I don't like this at all. This one's not got logs at all. It says log to the base 10, so it's the first one that we've seen that actually has a base number. But anyway, let's have a go at this. So this, I like this one. This I can just bring the 2 to the front. So this is log to the base 10 of 4 squared. And again, I can do the same with this one. I can bring that to the front. Minus log to the base 10 of 25. And notice it just becomes a power, 25 to the half. And I did mention, what do I do with ones we don't have anything on them? Now one thing I do know is log to the base 10 of 10 is 1. That's what I need to know. If it was log to the base 10 of 100, I know it's 2. And you can always count up the number of noughts you've got to give you the number. And I've got one, so I'm going to say plus log to the base 10 of 10 for that one. So that's worth knowing. What can I do with these? Well, let's simplify them. This is log to the base 10. 4 squared is 16. Minus log to the base 10. 25 to the half. That's like square rooting. That's 5. Plus log to the base 10 of 10. And my rule says if I add them, I times them. But if I subtraction, I divide them. So I reckon this is log to the base 10 of 16 times the 10, because that's the add, divided by the 5. And I think that's log to the base 10 of 32. Let's see if my answers are right. Yes and yes, so I'm happy with those. Oh, that was interesting. That was a better way of writing it. I didn't spot that. So 32 can be written as log to the base 10 is 2 to the 5. It's a power of 2. And therefore, at this late stage, I can still do more work. And it's 5 log to the base 10 of 2, which is where this answer comes from. I've got 3 questions for you. Have a go at those, please, and let's see if you can get some nice answers. Pause the video and see what you can do. And hopefully you've now looked at those answers. So let's just go through some answers. I'll just ping these up, see if these are the same as yours. Answer first one, I've got 2 log 5. Obviously 25 is 5 squared, so you can see the 2's come to the front. So if I write that as log of 5 squared, then the 2 comes to the front, I get 2 log 5. Log of 6, well, I've split that into log of 2 and log of 3, because this is really the same as log of 2 times 3. And when they're times, they become adds. So I like that. And, well, this is log of 10 to the minus 1, which means I can bring it to the front, minus log 10. But 10 is the same as 2 times 5, which is why I've ended up with minus log 2 minus log 5. See if you can get that if you haven't got that yet. That's perhaps the trickiest one we've seen so far. Next one, I've got 3, so the I suppose I'd think about this as it's a divide, so I'd split it into a minus. And as soon as you split it, you can bring the powers to the front, which is what we've done there. And this last one, you have to join them together. 3 times 5 is 15, divided by the 2 is 15 over 2. Move the powers. Oh, this one you're going to have as a base 10, I assume, but it doesn't say so. So this is really a 10. See if you can get 16 over 5. And I'm not going to bother with these because we're going to do more on solving logarithmic equations next time. In class, then, I want us to worry about that. But in class, we'll also be doing exercise 7b. So Hopefully that makes a little bit of sense for you, and you're okay. Well done.